Hello everyone, thank you for joining and welcome to today's webinar on selecting the right operating system for your embedded project. My name is Ali from Moraes and I work as a software engineer at Variscite. I'm excited to guide you through this very important aspect of embedded product development, which is choosing the most suitable operating system. Here is our today's agenda. We'll start with an introduction to Variscite. Then I'll discuss the importance of choosing the right operating system for your project and the main components of an embedded operating system. After that, we'll delve into the four major players in Linux-based embedded operating systems, the Yocto Project, Bootcute, Debian, and Android. I will also demonstrate how the process of adding and patching applications is done in each one of those systems we'll be discussing. And finally, we'll wrap up with the next steps. So let's talk about Variscite. Variscite is a leading name in the system of modules market, with 20 years of experience and expertise, and have built an extensive customer base and pipeline. Due to its internal production facilities, Variscite has complete control over the manufacturing process and a stable supply. Variscite software and hardware teams provide direct support to our customers, usually within 24 hours. Variscite is an NXP's Platinum partner, having early access to new products and softwares and features. We provide the most diversified i.MX-based product portfolio, and Variscite has the ecosystems of partners that allow us to offer complete end-to-end solutions for our customers. Variscite, we offer several key advantages. To start, most of our sound falls in two major families, the Dart and the Var sound families, and these are generally pin-to-pin compatible. While other sound vendors might only stock 3 or 4 variants of a sound, we offer the ability with any of our sounds to fully customize individual features like memory size, CPU core count, and other various on-sound peripherals. Our 100% yield performance ensures that everything is tested and validated before reaching a customer. Our customers can rest assured that the sounds they receive will be high quality and fully functional. Additionally, we provide production-ready hardware and software that has been tested and used by thousands of customers. It has proven high reliability and low risk. This, coupled with the free support we offer, allows our customers to accelerate their path to production. With robust longevity up to 15 years, our customers can rest assured that we can continue to supply and support them throughout the life cycle of their product. Here we have some examples of the Dart family. The Dart family shares the same connector that has more pins available in comparison to the Sound family. Its reference board is the DT8M custom board, in which you can plug any Dart module, replace the operating system, and then you successfully replace the module. We started with the 8M family, allowing the customers to scale from the Dart MX8M Mini all the way up to the Dart MX8M Plus. Now we are introduced the IMX90 family with the Dart MX91, Dart MX93, and Dart MX95. So you can even switch from the 8M family to the 9 family and leverage all of its new features. Here we have some of the advantages of the pin-to-pin compatibility. The main advantage is the scalability, where you can replace a module for another one of the same family, making changes only to your software so you can support the new module. There is no need to redesign your carrier board when scaling, optimizing the costs, because you can keep using the same carrier board for different modules with different features, facilitating the development process and the integration. And you also have the possibility of expanding the lifetime of your product, because you can migrate to newer modules that has been just released. Choosing the right operating system is a critical decision in any embedded project. The system you select will significantly influence your product's performance, scalability, reproducibility, distribution, and ease of use. It impacts everything from the efficiency of your development process to the user experience of your final product. In this webinar, we will explore four major players in the Linux-based embedded operating systems landscape: the Yocto Project, Qt, Debian, and Android. Each of these options offers unique advantages and challenges, and understanding will help you make an informed decision that best suits your project's specific needs. Before frameworks like the Yocto project revolutionized the process, building a custom Linux operating system for embedded devices was an incredibly complex and daunting task. It required lots of manual efforts to integrate and configure the various components that constitute an operating system. This process was not only time-consuming but also demanded extensive scripting skills to automate those tedious steps and a deep understanding of hardware architecture for proper configuration. Now let's talk about the main components required to build an operating system. First, we have the bootloader. The bootloader is the first piece of code that runs when you power on your device. Its primary function is to initialize the hardware, such as configuring the RAM and then load the kernel into memory. The bootloader ensures that the system is ready to boot the operating system properly. Then we have the kernel. The kernel is the core of the operating system. It manages all interactions between the hardware and the user space applications. This includes handling system calls, managing resources, and ensuring security and stability. The kernel is a key component for the overall performance and reliability of the system. The root file system contains all user space components, including applications, libraries, and essential packages. It provides the environment in which user applications runs and interact with the system. The root file system is fundamental for defining the functionality and user experience of the embedded device. In addition to assembling these components, developers faced other common challenges too. The development often relied heavily on the host computer's environment. This dependency could lead to the famous "but it works on my machine" problem, where software worked on the developer's computer, but it failed elsewhere due to the lack of the right dependencies. And other common issues were the creation of a consistent SDK that stands for Software Development Kit for application development was another hurdle. Developers frequently encountered mismatches between the development environment and the target environment, leading to integration issues and delays. Let's start with the Yocto project, a powerful and versatile toolset that has transformed the landscape of embedded Linux development. Yocto is not an operating system by itself, rather it is a framework. It is a comprehensive set of tools that allows developers to create their own Linux-based distributions. Yocto provides the flexibility to customize every aspect of your operating system, precisely to fit your project's requirements. The Yocto project is an open source collaboration initiative. It brings together developers from all around the world to work on creating customizable and maintainable Linux distributions. This collaborative nature ensures that Yocto benefits from a wide range of expertise and contributions, enhancing its robustness and versatility. One of the primary goals of the Yocto project is to simplify the inherent complexity of building and maintaining embedded Linux distributions, as we discussed earlier. With its tools, you can simplify the development process, reducing the effort and time required to create your own operating system. Yocto offers a unified build system that supports multiple hardware architectures. It simplifies development and ensures consistency across different platforms, whether you are targeting ARM, ARM64, x86, or another architecture. Yocto provides a consistent and reliable build environment. Yocto fosters a collaborative ecosystem where developers can share technologies, configurations, and best practices. By leveraging the collective knowledge and resources of the Yocto community, developers can achieve higher efficiency and better results. To sum up, Yocto is a powerful ally in the world of embedded Linux development. It provides the tool and documentation needed to create custom, high-performance Linux distributions tailored to the specific needs of your projects. Now that we have an overview of the Yocto project, let's delve into its pros and cons. Understanding both the strengths and limitations of Yocto will help you determine if it's the right choice for your embedded project. Before we start, I'd like to add a little disclaimer here. Everything we are going to discuss in this webinar regarding to the best choice of operating system, pros and cons, and so on, is based on the idea that we're working with Variscite System module. So keep in mind that those informations might not apply to other system modules and platforms. So let's start with the pros of Yocto. Yocto's ability to support various machines and architectures makes it incredibly versatile. Whether you're working with ARM64 or any other architecture, Yocto can handle the specifics, providing a unified development environment. One of the Yocto's biggest strengths is its high level of customization. You have the freedom to customize every aspect of the operating system to meet the exact requirements of your project, ensuring optimal performance and functionality. Yocto offers complete control over what goes in your operating system. This means you can include only the components you actually need, avoiding unnecessary bloat and potential security vulnerabilities. With Yocto, you can create predictable and reproducible images. This reliability is important for maintaining consistency across development, testing, and production environments. Yocto supports atomic updates with tools like SW Update, allowing for robust and reliable updates. This feature is vital for maintaining system integrity, especially in production environments. Creating an SDK for application development is really straightforward with Yocto. This ease of use accelerates development and ensures that your application's development environment is consistent with the target you are deploying. Yocto benefits from a strong community and vendor support. This network provides valuable resources, support, and shared knowledge, making it easier to solve problems and implement best practices. Yocto also has its cons, which are a steep learning curve. One of the main challenges with Yocto is its learning curve. Mastering Yocto's tools and processes can be time-consuming, especially for those new to embedded Linux development. Yocto has a very good and comprehensive documentation, but it is also very long, so it takes some time for you to get used with Yocto. Building images with Yocto can be resource-intensive and time-consuming. The build process requires significant computational resources, which can be a constraint for some projects. When you are adding new packages that come with additional dependencies, you often need to rebuild those new packages and even other existing dependencies from scratch. This requirement can add complexity and delay to the development process. While Yocto offers powerful tools and flexibility, it is essential to weigh those pros and cons in the context of your specific project needs and resources. Yocto's flexibility, level of customization, scalability, ability to support a variety of architectures and provide real-time capabilities and high-performance OS solutions that are optimized for the specific hardware makes it the go-to solution for embedded operating system development, unless a very specific constraint suggests otherwise. Yocto's versatility allows it to be used in a wide range of applications. Here are the most common use cases, which are industrial automation, automotive, consumer electronics, and Internet of Things. Yocto is also perfect for products that requires a custom or dedicated operating system. Its ability to fine-tune the operating system to the exact needs of the application ensures optimal performance and functionality. For applications need a reliable update mechanism, Yocto supports robust solutions like SW Update. This feature is key for maintaining device integrity and ensuring that updates are applied smoothly and securely. Yocto is an excellent choice for applications that demand enhanced performance, especially in critical and resource-limited environments. Its ability to strip down the operating system to the bare essentials helps in maximizing performance and efficiency. Yocto is advantageous when existing application needs to be patched and adapted quickly. Its flexibility and extensive support makes it easier to incorporate updates and modifications without disrupting overall system stability. Next, let's discuss Bootycute, another powerful tool in the embedded operating system landscape. Bootycute is particularly focused on simplifying the creation of user interfaces on embedded devices. Bootycute is implemented as a meta layer within the Yocto project. This means it inherits all the benefits of Yocto, including its flexibility, customization, and robust build system. By leveraging Yocto, Bootycute provides an efficient development experience. One of the key advantages of Bootycute is that it generally uses newer versions of Qt compared to Yocto's default Qt meta layer. This ensures you have access to the latest features, improvements, and optimizations that Qt offers, enhancing the overall capability of your embedded application. Qt is designed as a lightweight Qt-optimized stack for embedded Linux, leveraging performance-sensitive applications as it reduces overhead and ensures that the system runs smoothly and efficiently on embedded hardware. One of the standout features of Qt is its ability to simplify the creation of user interfaces on embedded devices. Qt is renowned for its powerful and flexible UI framework, and Qt brings this capability to the embedded world. With Qt, developers can easily design and implement sophisticated, responsive, and attractive user interfaces tailored for their specific applications, whether they are working on Mac, Windows, or Linux, thanks to its multi-platform IDE. In summary, Qt combines the strengths of Yocto with the advanced UI capabilities of Qt, making it an excellent choice for projects where user interface design is a priority. By leveraging the latest Qt versions and offering a lightweight optimized stack, Qt provides a robust solution for creating compelling embedded applications. Having introduced Bootcute, let's now examine its specific pros and cons. Since Bootcute is implemented as a meta layer within the Yocto project, it inherits all the pros and cons of Yocto that we previously discussed. Additionally, it brings its own unique set of advantages and challenges. The pros are that Bootcute is specifically optimized for Qt, significantly enhancing the performance of user interfaces. This optimization ensures that your applications run smoothly and responsibly, providing a high-quality user experience. Bootcute provides a comprehensive SDK tools and an IDE for rapid development. These tools are cross-platform, supporting Linux, Mac, and Windows, allowing developers to work in their preferred environment while maintaining consistency and efficiency in their development process. As cons, we have that while Qt offers powerful features, some of its packages, such as Qt Web Engine, can be particularly resource intensive. This requirement can pose challenges for projects with limited hardware resources or performance constraints. Managing these resources effectively is important for maintaining optimal system performance. And for product development, Bootcute requires commercial licensing. This necessity can add to the overall cost of your project. It is important to factor in this licensing cost when planning and budgeting for your development efforts. In summary, Bootcute provides significant benefits for creating sophisticated and high-performance UIs on embedded devices. However, it also comes with challenges, particularly in terms of resource demands and licensing costs. Evaluating these factors will help you decide if Bootcute is the right solution for your project, especially if user interfaces performance is a top priority. Having explored the pros and cons of Bootcute, let's now look at some specific use cases where Bootcute truly excels. As a Yocto meta layer, Bootcute inherits all Yocto's advantages, making it a robust and versatile solution for embedded development. It is particularly recommended for products that rely on appealing graphical applications, such as automotive infotainment, The systems require high-performance interactive display that provide a seamless and responsive user experience. Qt's optimization for Qt ensures that this infotainment system can deliver rich graphical interfaces and smooth interactions, enhancing the overall driving experience. Home automation. These interfaces need to be user-friendly and responsive, allowing users to easily manage their home environment. Qt's powerful UI capabilities make it possible to design attractive and efficient control interfaces that enhance the functionality and appeal of home automation products. User-friendly interface for critical applications. Whether it's medical devices, industrial control systems, or other mission-critical applications, having a reliable and easy-to-use interface is essential. Qt's ability to create high-quality user interfaces combined with Yocto's performance and stability ensures that users can interact with the system efficiently and safely. Its optimizations for Qt and robust feature set makes it an ideal choice for automotive infotainment, home automation, and user-friendly interface for critical applications. By leveraging Qt, you can ensure that your product delivers an exceptional user experience. Now, let's explore Debian, a cornerstone of the Linux ecosystem with a rich history and a reputation for reliability and flexibility. Debian was founded in 1993 by Ian Murdoch, making it one of the oldest and most respected operating systems based on the Linux kernel. A key aspect of Debian is its adherence to the Debian social contract, which prioritizes the principles of free software. This commitment ensures that Debian remains open, transparent, and community-driven. Debian's robust and flexible nature has made it the foundation for numerous popular Linux distributions. Some of the most well-known derivatives include Ubuntu and its various flavors, Linux Mint, Pop! OS, and many others. These distributions inherit Debian's stability and package management capabilities, making them widely used across different sectors. Debian is heavily used across a wide range of environments, from servers and desktops to embedded devices. One of Debian's most celebrated features is its robustness. The operating system is known for its stability and reliability, which are fundamental for both development and production environments. This robustness is implemented by Debian's simplified software management, making it easier for developers and administrators to maintain their systems. Debian boasts an extensive package repository, providing access to a vast array of software packages within various architectures, including ARM64, making Debian a versatile choice for embedded systems. The availability of a wide range of packages ensures that you can find the tools and applications you need for your specific project requirements. Debian uses the Advanced Package Tool or APT, for the easy installation and management of software packages. APT simplifies the process of adding, updating, and removing software, ensuring that your system remains up to date and secure with minimal efforts. Debian's long-standing reputation, adherence to free software principles, and robust package management makes it an excellent choice for a wide variety of applications. Debian provides the reliability and flexibility you need to build and maintain a stable and secure system. As all of the other operating systems, Debian also has its own set of pros and cons. The pros are that Debian's APT significantly speeds up the prototyping process. With APT, you can quickly install and manage a wide range of software packages, making it easier to set up and test your development environment. Debian is renowned for its stability and security. Its rigorous testing and update process ensures that you have a reliable and secure operating system, which is essential for both development and production environments. Debian has a large and active community, along with extensive documentation. This richness of resources makes it easier to find solutions to problems, learn best practices, and get support when needed. Deploying applications and updates is straightforward with Debian packages. This ease of use simplifies the maintenance and updating of your system, ensuring that your application remains current and secure. Uh, And we also have the cons, which are that Debian distributions often include a wide range of components, some of which may be unnecessary for your specific use case. This can lead to larger system footprint than needed, which might be a drawback for resource-constrained embedded systems. While Debian is versatile, it is not specifically optimized for embedded systems. This lack of optimization can result in less efficient performance compared to other operating systems specifically designed for embedded application. For SoC-specific softwares like GPU and NPU drivers, you need to create and maintain custom packages. This requirement can add a lot of complexity and effort to your development process. Debian updates are not atomic, meaning they do not complete as a single indivisible operation. This can potentially lead to issues if an update is interrupted or fails partway through. Updates in Debian are not always consistent across different devices, which can lead to discrepancies in software version and configurations, complicating system management. Customizing existing applications in Debian can be challenging. Unlike some other OSs that are designed with flexibility in mind, Debian's structure may require more effort to adapt applications to your specific needs. Debian does not provide a dedicated software development kit, which means that application must be compiled on the target device or using chroot environment, which can complicate the development workflow. Debian offers many advantages such as stability, security, and a rich package management system, making it a strong candidate for various applications. However, the lack of optimization for embedded systems and the additional effort required for customization and SoC-specific software maintenance are important considerations when evaluating its suitability for your project. There are specific use cases where Debian proves to be a valuable choice, especially for embedded applications. Debian is ideal for fast prototyping. Its straightforward installation process allows you to set up a development environment quickly. The apt is a powerful utility that lets you seamlessly install, update, and manage applications and packages. This efficiency accelerates the development cycle, enabling you to move from concept to implementation very rapidly. Debian is also well suited for embedded applications that require a wide range of easily installable software. Whether you're working on industrial automation, IoT devices, or consumer electronics, Debian's extensive package repository provides the tools and applications you need, ensuring that you can meet the diverse requirements of various projects without extensive customization. Debian's robust package management system and update capabilities are beneficial for systems where maintaining and updating software is fundamental. The use of managing packages with apt ensures that your system remains up to date and secure with minimal effort. This feature is particularly important for applications that require regular updates and reliable software management. Summarizing, Debian's strengths in fast prototyping, extensive software availability, and robust package management make it a compelling choice for a wide range of embedded applications. And finally, let's discuss Android, a widely used platform that extends far beyond its origins as a smartphone operating system. Android was developed by Android Inc., which was acquired by Google in 2005. The platform was officially unveiled in 2007 and has since become the world's most widely used smartphone operating system. Its evolution under Google's stewardship has ensured continuous innovation and widespread adoption. Android is maintained by Google under the Open Handset Alliance. This consortium of companies drives the development of Android, ensuring a high degree of standardization and compatibility across a multitude of devices. Google's involvement guarantees regular security updates and feature enhancements, providing a stable and secure platform for developers and users alike. Beyond mobile phones and tablets, Android powers a wide range of consumer devices, including smart TVs, wearables, and automotive infotainment systems. This versatility showcases Android's adaptability to various hardware platforms and use cases. Android is based on the Linux kernel, which has been specifically extended for the use in embedded systems. This foundation allows Android to leverage the stability and robustness of Linux while adding layers of functionality tailored for embedded applications. Android has a vast ecosystem of apps, tools, and a global community of developers. This extensive support network makes Android a versatile platform for embedded development, providing numerous resources for innovation and problem solving. Android supports Widevine DRM natively, facilitating the secure delivery and playback of DRM-protected content. This capability is crucial for applications requiring content protection, such as streaming services and digital media devices. Android offers a rich user interface and a vast array of available apps and services. Its flexibility and comprehensive toolset make it a powerful option for embedded system developers. Android's extensive development history, robust maintenance under Google, and its versatility across a wide range of devices make it a good platform for embedded development. Its rich ecosystems and adaptability ensure that it can meet the needs of various embedded applications. Let's discuss the pros and cons of using Android for embedded development. On the pros, we have that Android has a vast ecosystem with millions of apps available. This extensive application base provides a wide range of functionalities that can be leveraged in embedded projects, saving development time and effort. The Android community is one of the largest in the world. Both Google and the community provide extensive support, including throughout documentation, forums, and resources for application development. This robust support network helps developers overcome challenges and stay updated with the latest advancements. Android Studio offers a complete environment for application development, including tools for building, testing, and debugging. Its IDE is powerful and user-friendly, facilitating the development process. Android provides a comprehensive SDK that simplifies application development. The SDK includes libraries, tools, and documentation necessary for creating robust applications. Android natively supports Widevine DRM, facilitating secure media distribution and playback of DRM-protected content. This feature is particularly valuable for applications involving digital media. SE Linux, or Security Enhanced Linux, enables protected access to hardware resources, enhancing the security of the system. This security feature is vital for protecting sensitive data and ensures system integrity. And on the other hand, we have the cons, which are that Android has higher system resource requirements compared to other embedded operating systems. This can be challenging for low-spec devices, limiting its use in resources constraining the environment. The complexity and size of Android may not justify its use in projects with minimal requirements. For simple applications, the overhead of Android's extensive features might be excessive. Keeping up with the latest Android versions can be difficult due to significant changes and the extensive testing required. Each new release may introduce changes that require considerable effort to integrate and test. Android releases sometimes introduce significant changes, such as partition counts, which can make updates difficult to nearly impossible. These changes can complicate system maintenance and deployment. Documentation and support for BSP development in Android are limited. This can pose challenges for developers needing to customize the operating system for specific hardware. The Android SDK cannot directly access hardware, which can be a limitation for certain embedded applications that require low-level hardware interaction. While Android is customizable, making deep changes requires significant effort and expertise. This complexity can be a barrier for developers looking to customize the system extensively to their needs. Managing SC Linux is complex and requires experience. It can complicate access to hardware relative to other options in the OS realm, adding to the development effort required to ensure security and functionality. Summarizing, Android offers a rich ecosystem and robust development tools, making it a strong contender for many embedded applications. However, its higher resources requirements and complexity can be challenging for certain projects. Let's talk about specific use cases where Android is a viable option, particularly in the context of embedded applications. Android is an excellent choice for applications require DRM protected media playback. Thanks to its native support for wideband DRM, Android ensures secure delivery and playback of DRM protected content. This feature is vital for applications like streaming services, digital signage, and any other use cases involving protected media content. Or for companies or products that already have a team of Android developers or an existing Android app ecosystem, Android is a natural fit. Leveraging the existing expertise and resources can accelerate development and reduce training costs. Android make it a good choice due to its DRM protected media playback and its extensive developer ecosystem. As we reach the end of our introduction to the operating systems, let's summarize and compare the operating systems we've explored to help you decide which one best fits your project needs. Again, keep in mind that the comparison we are making makes sense when talking about Variscite system modules. Yocto is generally the go-to choice for embedded operating systems development due to its unmatched flexibility and customization. It optimizes performance and resources usage, minimizes the system image footprint for efficient storage and faster boot times. Yocto also ensures build reproducibility, which is vital for maintaining consistency across different development and deploying environments. Additionally, it simplifies SDK creation, making it easier to develop and deploy applications consistently. Qt combines Yocto's customization and efficiency with the Qt application framework for advanced interfaces development. It is ideal for creating visually appealing, responsive UI applications with minimal overhead. By enhancing the user experience while maintaining performance and resource optimization, Qt is a perfect choice for projects where a sophisticated user interface is a priority. But don't forget to take into consideration that Qt requires a commercial license. Debian is a strong candidate for rapid prototyping and straightforward updates via apt. It offers stability and a vast software repository. If your project benefits from a stable, well-documented environment with extensive package availability, Debian is a solid choice. Android will be the natural choice for projects that can leverage existing Android development expertise and its extensive app ecosystem. It is particularly ideal for DRM-protected media distribution thanks to its native support for wideband, ensuring secured content delivery. If your application involves media streaming or you already have a team familiar with Android development, this platform provides a significant advantage. So after all of our discussion, I would say that Yocto will be the winner when you are choosing your operating system. We at Variscite we will always prioritize Yocto as our recommendation, as it is often the best choice available. Of course, there are cases where you may want to use the other options, but those are very specific use cases. So in general, you will want to stick with Yocto. So now let's start showing how the adding and patching an application process is done depending on the operating system you choose. From one kind of operating system, it might be more simple or more complex. It will depend on the kind of application and the operating system itself. So starting by Yocto, first you need to set up your host computer to use Yocto. Don't worry about memorizing all of those steps. For in the coming days, we are going to make this presentation available, and all of those steps are also available at Varisite's wiki. So here we show how you install the required packages, and we are taking into consideration that the host PC is Ubuntu 22.04 That's where all of those steps are going to work properly. So first you're going to need to install all the packages required by Yocto, configure your GitHub username and user email. You're going to download the REPL tool and use REPL to initiate the manifest to fetch all the metadata required so you can start building your Yocto image. Now that you have your building environment set up, let's create a meta layer where we are going to add our recipe. A meta layer is a collection of recipes, configurations, and other files that define how to build specific software packages and configure the build environment. Meta layers provide a modular way to manage and customize the software stack for embedded Linux systems. They help organize and isolate different components of a project, making it easier to manage, share, and reuse code. We can use Bitbake Layers tools to create the meta layer, and then we are going to add it to our bblayer.conf file. After that, we are going to create a recipe that adds our application to the Yocto image. In the Yocto project, a recipe is a file that contains the instruction for fetching, configuring, compiling, and packaging a specific piece of software. These instructions are written using the Bitbake build tool, which Yocto relies on to perform the build process. Recipes are fundamental to defining how the software components in an embedded Linux distribution are built and integrated. On the left side, we have an example of a recipe to build the HTOP application. Our build environment already includes the HTOP recipe, but some applications need their recipes written from scratch. After the recipe is completed, add it to the local.conf file so the image includes the application when it is built. Then you can build the image and have your application installed. For Debian, adding applications is a really straightforward process. That's why Debian is a very good choice for prototyping purpose. As you can see, to install the htop application, you just have to run apt install htop, and you are going to install the same application you installed with all those steps we did in Yocto. If the application is not available in the Debian repository, you have to download its Debian package and manually install it, but the process is still straightforward. Adding applications to Android requires a more manually process that reminds what you did for Yocto. It's not the same process. They use different build systems. So first you're going to need to set up your environment like you did for Yocto. And after you have the environment set up, you can go to how you actually add the application. After you set up your Android build environment, you can add the application. For that, you are going to need to add the source code of the application to this directory under vendor Variscite. After you clone the source code of the application, you have to create an android.mk file inside the application directory. The android.mk file is similar to a Yocto recipe where you add all the configurations you need for Android to build the application. So you're going to set up the path, the flags for building, the source files that are going to be built, the dependencies, and so on. The HTOP application, it depends on the anycurses library. Android does not include the anycurses library natively, so you also need to add it manually. The process is very similar to adding an application. You're going to need to clone the source code, create an Android MK file, and fill the Android MK file. After you created the Android MK file for the N curses, you will need to generate the source codes for the term info that are used for N curses and HTOP. And after you set everything up, you can proceed with building Android. And then after build Android, you're going to have HTOP and its dependencies included to the image. Here we have another example of how you add an application to Android, but here we have a much simpler application. Even though the process is the same, the configuration is much simpler as the source code it requires less instructions in the Android MK file. This application does not need an external dependency, so it's a more straightforward process to add a simple application. So you can see that Android, adding an application to Android, complexities will depend on the complexity of your application. So it might be simpler, like via my or might be some more complex process like we did for HTOP. Now let's talk about how we patch an application. Patching an application is basically you will take an application that is already been installed or built in your image and you have to make some changes because the application needs to meet some requirements and so on. So, for example, if we want to patch the HTOP we added in the previous section, we need to clone its source code. We are going to check out to the same revision that of the application that is being installed. We make the changes we want to the source code, and then we create a patch file containing these changes we made. After that, we are going to send that patch file to our custom layer where the recipe is present. And on the right side, we need to add those two lines in green. The first line, the first line says to the build system where you can find the file, and the second line says to the build system which file you are going to use to apply the patch. After you created your patch and modify the recipe, you can rebuild your image and the patch is going to be applied and the application is going to be rebuilt from source again. And then it will be installed. Here we have an example of how to patch an application on Debian. As we saw in the previous section, adding an application to Debian is a straightforward process. On the other hand, patching an existing application is a more complex task. We need to follow some steps before. So first, we need to set up a cross-compile environment on our machine to build an ARM64 application. We need to install the required packages, use the bootstrap to create a minimal ARM64 Debian file system, use QEMU static binary to emulate an ARM64 environment on chroot, actually start the chroot environment and set up the basic configurations for that environment. After that, we set up the deb source repository so we can fetch the application source code. After we set up the repositories, we can get the source code by using apt-get source and the application. After that, we enter the applications directory and we will use Qt to keep track of the changes we are going to make to the source code. This way we can create patch files that are used to update the application. After we made all the changes to the source code, we will use Qt again, so we can create the patches. You are going to do this by running Qt refresh. After that, we can change the Debian packages changelog to add the changes we made. And then we create the Debian package using the debut command. After the Debian package is created, we can send the package to the board and install it in the board using the pkg -i and the package name. And that's it. You changed the application and then you installed it again in your board. And to patch an application on Android, it's a kind of simple process. Considering that you already added the application before, you can navigate to where you cloned your application, make the changes direct to the source code, and then rebuild the application again. And then your application is updated. Now let's talk about the next steps on how you can choose the best operating system for a project. Now that we discussed about the different operating systems, we know that this choice is a critical decision that should align closely with the specific needs and goals of your project. Whether you're developing for industrial automation, consumer electronics, or anything in between, understanding the unique strengths and challenges of each operating system is fundamental. The previous mentioned operating systems offer their own set of advantages and disadvantages. Understanding and exploring them is the key for making the best choice for your product. Making an informed decision about which operating system to use can significantly influence the success of your project. It's about balancing the technical requirements and constraints of your projects with the capabilities and features of each operating system option. Remember, there's no one-size-fits-all answer. The best choice depends on your project's unique requirements. We at Variscite know that not only choosing the operating system, but also start creating, testing, and validating is not easy feat. We developed a comprehensive developers week where you can navigate the complex landscape of embedded operating systems options, experiment, learn, and start setting up your operating system and applications. You can also read the blog post that Nate Drew wrote about selecting the right operating system for your embedded project. Please feel free to reach out to us at our website via email, our customer portal, and be sure to check out our wiki and GitHub pages. I hope this webinar helps you in selecting the right operating system for your embedded project. And thank you for joining and stay tuned for the next Variscites webinars.